Hi, my name is Taylor Didomenico, and this is my final project for statistics of summer 2024. Our objective is to explore if increased outdoor activity and working out limit screen time and social media use. My hypothesis is that people spend less than 3 hours a day participating in outdoor activities daily, and I want to explore how different social media apps influence how much time you spend outdoors and how they correlate. So, for this project, we were assigned to pick 2 quantitative questions, 2 categorical questions, as well as 1 binary question. So, a quantitative question is something that can be measured in numbers. And for my first question, I chose, in a span of a week, how many hours do you spend solely on entertainment applications? And for my second quantitative question, I chose, how many hours did you do an outdoor activity per day this week? I also have 2 categorical questions, one of which being, what type of app do you use the most on your phone? And the options for responses included and were limited to social media, streaming, such as YouTube, Netflix, Hulu, games of all different sorts, the internet. These are just internet browsers, including Safari and Google Chrome, school apps, so including Canvas and Genius Scan, which we used heavily for this class. And then food apps, including, DoorDash, Uber Eats, and Instacart. The second categorical question I chose was, what do you do when you go outdoors? And this question wanted you to select, when you were outdoors, what was how did you spend the majority of your time? The selections included and were limited to exercise, walk, play sports, experience nature, garden, go to the park, and other. And then I also chose 1 binary question. A binary question is a simple yes or no question. And the one I chose for that was, do you try to limit your time on social media? So these are the questions that I found valuable and genuinely contributed to my project. How many hours did you do an outdoor activity per day this week? This is critical to my project because it is the main source for my hypothesis test, and it's a quantitative question which provides us with more numbers and a easier route to calculate R values, correlation, regression lines, all sorts of summary statistic numbers. Another question I found valuable was, in a span of a week, how many hours do you spend solely on entertainment applications? I found this valuable because I wanted to compare it directly with how many hours you spend on an outdoor activity per day. I wanted to see this correlation and regression line to see if this correlation was what you would expect, which is that as your outdoor activity per day increases, your hours spent on entertainment applications would decrease. I also found my binary question to be valuable because this is a clear question that you would think would directly correlate with the amount of hours spent on entertainment applications. So 2 of the problematic questions that I considered problematic was my two categorical questions. One of which being, what type of app do you use the most on your phone? I found this to be problematic because categorical questions don't provide any quantitative data, but they do allow you to group your quantitative data by said categories. The other categorical question that I found problematic was, what do you do when you go outdoors? And this is due to the fact of there being an other option, as well as the categories not being as specific as you'd like to find true data. Another issue with these categorical questions was some of the options did not have a large enough sample size to even group the data by. So I was forced to ignore some of the categories for what do you do when you go outdoors. So how is data cleaned? And is it an errorless transition from non-clean data to clean data? No, it is not an errorless transition. When dealing with surveys that are self-filled out, we find there can be a lot of questionable entries, as well as unnecessary repetition and just issues that make the data slightly unclear in certain circumstances. A few entries that can be cleaned without errors was 10 HRS dot and 1 HR. These are easy to clean because it is crystal clear that the only error here is the individual who filled out the survey decided to repeat the unit of measure. And StatCrunch does not like letters and numbers together. So to clean this data, I just deleted the unit of measurement and left the quantitative value. So 10 for 10 hours and 1 for 1 hour. Now, a couple entries I saw that cannot be cleaned without errors is this squiggly line 1, which the only safe assumption for that is hopefully it's about 1 hour. And other entries that make it difficult are when the individual who filled out the survey provides a range. Now, the about one is pretty clear why it'd be problematic. This is because, I have no idea what about one means. People exaggerate and people use that verbiage differently. So there is no way to tell what they truly mean or what the true data is. And as for range, StatCrunch also does not enjoy ranges. And given a range, after speaking with Dr. Frederick, the only option I had was to find the average within the range or the mean and clean it that way. Now, this can absolutely harm the integrity of the data, and I tried to do this as little as possible to keep my project as clean as possible. Now, we'll get into each question and a histogram and a pie chart easily displaying the data and how it works. So, our sample size was 84, which is not terribly small, but obviously it's not ideal. It's slightly smaller than what we would prefer. And as you can see on the histogram on the right, the data is heavily skewed. We see the frequency on the left side of the histogram extremely high, while the right side only contains an outlier. And this outlier was extreme because, as you can see, on the x-axis, it is our weekly hours spent on entertainment apps. And 150 hours weekly is about 20 hours a day, slightly more. And that's just not possible. So I would assume that this was a typo or someone, as they say, fat-fingered it, but I am not completely sure. on why they would fill the survey out with that data. I enjoy this pie chart because it shows our frequency a little bit clearer, and it also gives us percentages of the whole sample size. So, as we can see, people who spent 0 to 20 weekly hours on entertainment apps made up about 77% of our sample size, while 20 to 40 hours made up about 13%, 40 to 60 hours made about 7%, 60 to 80 hours made about 1%, as well as 140 to 160 hours, which we know there is something wrong with that outlier. Here is another question, my other quantitative question, which was, how many hours did you do in outdoor activity this week? Again, we see some weird outliers here. So this question was specifically for this week, which is the summer months. So I would assume we would see increased hours spent on outdoor activities. But this is the hours spent daily on outdoor activities. So given that, and we know our unit of measurement is an hour, we can see two outliers immediately that are impossible, right? We know no one could spend 30 hours daily on outdoor activities. We also know they couldn't spend 25 hours because there's only 24 hours in the day. And while this data is a little bit more spread out than our previous question, it's still heavily skewed. And there is clear individual error when filling out the survey that heavily impact our data by being impossible. The only assumption I could make, and I did not make this when cleaning my data, was that they assumed this was weekly, and I could divide that number by 7 to find the average hours spent daily on outdoor activities. Now, let's get into the categorical data. What type of apps do you use most on your phone? On the right, we can see a pie chart, which again, I enjoy because it clearly shows the true proportion of the data compared to the sample size, and it displays the percentage on the key on the right of the chart itself. So the pros of categorical data is that it eliminates people having to fill out their own data, which makes the user error pretty much 0. Unless they select the wrong option, it is 0. Now, the cons of categorical data is that, maybe not all of these categories, maybe this isn't enough categories where people felt that they had to compromise when selecting a choice. But frankly, the categorical data is really easy to understand on a pie chart. And as we can see, people that played games on their phone took up about 2.4% of the sample size. People that use school apps majority of the time took up about the exact same percentage at 2.38. People that use social media the most were about 70%, and we can see that in green. People that used streaming the most, 16.67%. People that use Safari and Google Chrome, stuff like that, about 8.33%. On to what do you do when you go outdoors? This is another categorical question, which gives people a simple 7 options to pick between for what they do most while doing outdoor activities. So, activities done while outside included exercise, which took up about 22% of the sample size. And we see there it is 18 people out of 84. People that go outside to experience nature was about 9.5%. People that garden was just over 1%. People that go to the park was at about 3.5%, 3.6%. Other took up about 20%. People that play sports majority of the time while they're outside was about 12%. And people that just walk It's about 32%. So judging the substance of this data, what I mean by that is that we have this other category, which was selected by 20% of our sample size, and we have no idea what they're referring to. And this is just not as specific as I would personally like, but for now, it will work. Do you try to limit your time on social media? This is our binary data. Some of the pros of binary data, crystal clear. Yes or no. You only have two options, and it doesn't get much simpler than that. Cons, it is also so simple that it's hard to get much substance from this data. So our results were people who limit your time on social media. This is our binary data. Some of the pros of binary data, crystal clear. Yes or no. You only have two options, and it doesn't get much simpler than that. Cons, it is also so simple that it's hard to get much substance from this data. So our results were about 31% of people did not try to limit their social media use, while about 69% did try to limit their social media use. So here are our quantitative summary statistics. Now, why are they only quantitative? Because it is impossible to get any summary statistics such as mean, standard deviation, median, range, from any sort of data that doesn't contain numbers. So quantitative was the only two questions that I could pick from that would supply me with some summary statistics. Weekly hours spent on entertainment apps. For this, again, on both, we see N, which stands for sample size, being 84, as stated previously. On the top one, weekly hours spent on entertainment apps, we have a mean of 13.84 rounded and a median of 8. So here we clearly see that outlier affecting this data by making the mean higher than the median, significantly higher than the median. And we see a large range compared to our other question. So minimum being 0 hours spent on entertainment apps, and the maximum being 142, which is, again, over 20 hours a day. Nearly impossible. I can't imagine anyone is getting 4 hours of sleep and watching and using entertainment apps the other 20 hours of their day. On to how many hours did you do in outdoor activity this week? We see a smaller range with the minimum being 0 and the maximum being 30. Again, 30 hours a day is impossible, but for now we're just going to use the data that we have. So we saw a median of 3 and a mean of 4.15 rounded. And again, you can toss this up to a smaller range, but the fact that these numbers are relatively close, I found that data a little bit more satisfying personally. So now let's look at our regression line and how this data relationship works, and kind of what we can assume from the relationship. So, surprising results. This using common sense, this was not what I expected. As we can see on the line, as your hours spent daily on outdoor activities go up, the weekly hours spent on entertainment apps actually went up. This is slightly surprising, and I found it kind of shocking given the data we have. So clearly, again, I cannot emphasize this enough. Certain outliers were alarming, to say the least. That on the top right, we see 30 hours daily spent and 142 hours weekly. I mean, this is a busy man or a busy person. The other alarming outlier is the other person that put over 24 hours on daily outdoor activities. Again, this person is apparently very busy, and unlimited energy. But our R value was 0.54413,468. And this shows us that we have a strong positive relationship. So there's some clear correlation here. Now, this was when I grouped that previous data by the apps most used. I only had 3 choices here because the other categorical data options did not have a large enough sample size to provide any sort of regression line. But we have social media on the left, streaming in the middle, and the internet on the right, so internet browsers. So we can see here, the middle one, streaming apps, matched most with our original data without grouping it by apps used. And our social media weakened the relationship pretty severely. The streaming apps did show a weaker relationship, but I wouldn't say it was a significant difference. And I'm just comparing these that our R value on streaming apps was 0.244,85331 compared to our original, which was 0.55, blah, 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 blah. And our streaming apps had an R value of 0.394368. And this is much closer to the 0.55 and still shows a strong positive relationship. While when grouped on the internet, we saw a very weak but negative relationship, which is more to what I would expect. Also, given the sample size of the internet browser apps, it makes it very hard to bring any legitimacy towards that relationship and correlation. Now, this was my hypothesis test. So the question I used was, how many hours a day do you spend doing outside activities? And my hypothesis is that people spend less than 3 hours a day on outside activities. I assume that because given my current situation, working full time, it's hard to even spend 3 hours a day on outdoor activities. So I wanted to test this, and my null hypothesis was that people spend 3 hours a day on outdoor activities, while my alternative hypothesis is that people spend less than 3 hours a day on outdoor activities. The mean for our sample size was 3.79 hours, and the standard deviation 4.16 with a sample size of 84. The z-score ended up being 0.1904, while the p-value was 0.8490. So in conclusion, our p-value was significantly greater than alpha, and we failed to reject our null hypothesis, but there was not significant evidence to accept the alternative hypothesis either. Here are our confidence intervals going from 0.9 on the far left to the middle of 0.95 and the right 0.99. Here, the most important thing that I like to look at is the lower and upper limit. So as we can see, if we want to be 90% confident, our lower limit is 1.27 rounded, and our upper limit is 3.16 rounded. So this we see a relatively small range, and we can be 90% confident that any data value in our sample will be in between those two values. Now our 95% lower limit was 1.08, and our upper limit is 3.34. And here we see a very slight difference in our upper and lower limits from 90%. And that's just due to us having to be 5% more confident than before. Now, at 99%, we expect to see the largest range, which we do, with our lower limit at 0.7125 and our upper limit at 3.71. So my final thoughts for this data was that the correlation that we expected, given that, outdoor activities would limit your screen time and social media use, was untrue. And we actually found the relationship to be the opposite, whereas outdoor activities increased, as did the use of entertainment apps weekly.